Yeah, ndakulandani guys munsiku lero limene likhale kuphunzira zokhuza ndi integration in calculus. Ndeno tiye ndikhale limodzi tione kuti akamati integration ndi chani. Okay, first of all tiye tione apa. The integration in calculus is what does the opposite of differentiation. Komanso integration in another term can be as antiderivative. Yeah, and the integration it is made up with an elongated s, which is taken from the first letter of the word sum. Because integration it is like add up or sum in other aspect. Yeah, that is. And the integration is composed with several components. First of all, it is composed with the symbol, which is an elongated s, and it is also composed with an integrand and the variable of integration, and it's with respect. Yeah, we can see here it's the antiderivative, and its symbol is an elongated s. It's taken from the first letter of the word sum. Yeah, and it is composed with elongated s, integrand, and the variable of integration and its respective letter. See? Yeah, I think now we are together. And for us to be together, we need to see the symbol actually. Okay, let's move on. Yeah, this one. This symbol is called integration. Yeah, this symbol is like what does the opposite of differentiation. Yeah, and this symbol I said already, it is an integral sign. And this one it's an integrand, and this one it's a variable of integration, and this one that is at the end dx, it is with respect to x. And when we want to read this one, it is an integral of, which means we will read it as integral of f of x with respect to x. Okay, here it can be a t, it can be r, it can be r. Here will be also r. When here there is r, which means this one will also take a letter of r. When there is t, it will also take a letter of t. Yeah, you can see. Note that the symbol of integral also means to add up. See? Yeah, that's it. Let's move on. Okay, now we have types of integral. When we talk about types of integral, we have indefinite integral and we have definite integral. Okay, how can we know that this one is indefinite integral and the definite integral? Okay, we can know them according to their symbols. Okay, we can see here indefinite integral is written as here. Okay, it doesn't have anything on its symbol. Yeah, the remaining part is similar to the general symbol that I show you. Yeah, this one is similar to the remaining part. Okay, like I said, like sometimes it seems like the general symbol of integration, which is the indefinite integral. Yeah, and the indefinite integral is the reverse of differentiation, because most of the times it just gives us the function or a family of function. When you talk about indefinite integral, it just gives us the function or a family of function. Yeah, let's go to another type. Okay, which is the definite integral. Definite integral, it is composed with limits of integration. We have upper limits, which is b, and we have lower limits, which is a. See, and the definite integral most of the times it is used for finding area and volume. That's why its output is always a number, which means you can able to differentiate definite integral and indefinite integral. Definite integral, its output is a number, while indefinite, its output is a function. See, this one it has limits of integration, upper limits and lower limit, while indefinite it doesn't have any limits. See, okay, now we can go and solve on the board. Now let me take you on my board so that we can verify, we can see how we can reverse, since we say that indefinite integral is a reverse differentiation. Okay, let's move on to the board. And for us to see how we can verify that we done an integration process, we need to have a function that we will differentiate, thereafter we will integrate. See, okay, let me write a function that we can differentiate. Okay, let us assume that we have the the function of f of x is equal to x squared plus 4. See, once we differentiate it, we will come up with the differentiation of f of x will give us 2x. You see, once we integrate it, let's say we want to integrate this one. Okay, we integrate it in a way that we have an integration symbol and the radar and the function that we have, which is x 2x, yeah, with respect to x. Each answer will be x square. You see, because it's like we take the reverse, we take the reverse. But as we see on the original one, we have a constant, right? We have a constant, and this constant, it starts with the letter c. We will assume that constant will be c because we can't find the constant immediately. Yeah, and we will say that the constant of this one will be c. You see, yeah. We can also have another function because we can have several functions of the same family, but their constants can differ, so we can't guess about the constant. That's why we put the letter c to stand for any constant. See, okay, let me show you another example. This, we have f of x is equal to x squared plus 7. Now this one is 7. You see, once we differentiate it, we'll have 2x, but the constant is not there, which means when we integrate it, it just gives us x squared. See, the integral of this one with respect to x, yeah, it will just give us x squared, but we don't know the constant because once we are differentiating the constant number, it gives us 0, and we can't assume about the constant number. You see, and then we'll come up with the constant, which is just put c. Yeah, and here is where we generate the formula for integration. Let me read this so that we can write the formula of integration. As we see from the first equation that I write, yeah, this one, f of x is equal to x squared plus 4. Once we differentiate it, it gives us 2x. Yeah, and then it just gives us the, once we integrate it, once we integrate 2x with respect to x, it gives us x squared. You see, and maybe for us to have a clear picture, let me show you another example, but with different power. Yeah, let's take power 3. It's power 3. Yeah, power 3, maybe plus 4. Yeah, once we differentiate this one, it gives us 3x squared. Then 4 will give us 0. Thereby we don't consider 0. See, yeah, which means this one is the differentiation of the function of x cubed plus 4. You see, and then what I want to take you from to is that when we integrate this one, integrate it, yeah, 3x squared. Once we integrate it with respect to x, yeah, to give us x to the power 3. You see, yeah, to give us to the power 3 and plus a certain constant. Yeah, that is, and we can see a certain pattern here. You can see a certain pattern. Okay, that pattern is that let's assume that you have a constant number a and a variable x and a constant, another constant n. What is happening is that when we are differentiating, we take subtract n by 1. It we are subtracting it by 1. Assume we say that the indefinite integral is the reverse of divisation, which means we need to follow the reverse of everything. Okay, the reverse of subtract is what? Add, which means we will add 1. Let's add up 1 here, you see, to the power, and then we put it on the front of the variable. Right? We put it in the front of the variable to make it as a product, and we know that the product, it works with division, which means the opposite of product is division. Then we will take this one that we add on top of it, like we want to divide it with the constant number and the variable, which means we come up with n plus 1. That is the general formula that we can use to integrate things, like maybe integrate a x to the power n with respect to x. Just give us this one plus c. You see, this one is what is called the general formula of integration for a power function. See, that is what we're going to use. I think now we are together. You can have some, maybe some, you can take some papers that I will send you a link, so that maybe you can practice about how we can deal with the indefinite integral. Thanks for being with me. Goodbye.